On 4.7, number 3, they ask for the x and y intercepts of these graphs. Very key points on a graph as you move through algebra and into pre-calculus is where do they cross the x and y axis? That's what an x and y intercept. That's what x and y intercepts are. So keep in mind a couple of basic points. An x-intercept, I'll show in blue on this graph. So if I have this green graph and it does something weird like this, okay? There are graphs that do that in math. The x-intercepts are the points at which it crosses the x-axis. So what do they all have in common? One's over here, one's over there, one's way over there. They all have to have something in common, though. You know what it is. Not x equals 0. They're all on the x-axis, so y equals 0, right? This one, for example, might be -3, 0. This one might be 1, 0. And this one might be 3, 0. What do they all have in common? 0 for y. So an x-intercept is when you have some unknown value, comma, 0. So to find an x-intercept, you plug in 0 for y. On the flip side, oh, by the way, how many x-intercepts could a valid function have in math? How many x-intercepts, how many times legally could a graph cross the x-axis and still be a function? An infinite number of times, right? And lots of graphs do. Lots of the functions you'll see in pre-calc called the sine function and the cosine function, they go on forever like this, and they cross multiple times. Also, a graph, a function, could have no x-intercepts. Think of a parabola shifted up 6. How many times, whoa, what's that? How many times does it hit the x-axis? None. If it's up here, it never hits. It might have 0. So anything goes for the x-intercepts. The y-intercept, however, how many could there be? 1 or none. And that's it. There could be one y-intercept. There could be no y-intercept. Usually, they have one. It's rare that they don't. Here's an example of one that doesn't have a y-intercept, though. How about a radical function? Shifted right 2 and going that way. How many times does it hit the y-axis? Never, right? It never hits. So that would be an example that does not have a y-intercept. What's true about all y-intercepts, though, if there is one? If it crosses the x-axis, if it crosses the y-axis, what's x? 0. They're all 0, comma something, and that's a y-intercept. 0, comma something. So I suggest in number 3 that you go through A through F and you find the y-intercepts first, because they're easier. So the y-intercept in A is 0, comma what? All you have to do is plug in 0 for x and calculate. What's 1 minus 0? Come on. 1 minus 0 is 1. What's the square root of 1? 1. Then you got to apply the negative, so the y-intercept is 0, -1. While I'm over here, let's go down to D and find its y-intercept. Put in 0. 0 times 4, 0 squared. 1 minus 0, square root of 1. 1 times -2, 0, comma -2 is the y-intercept. The x-intercepts are a little trickier. They involve thinking. That involves thinking as well, but this involves a higher level of thinking because it's more of a what-if game, or how do I make this become 0? That's a higher level of thinking than putting a number here for x and just calculating. calculating is what you've been doing since kindergarten. Thinking about what does it need to be, that's more of a higher level task, even though you have been doing it since elementary school with stuff like this. What's 9 plus blank makes 11? You do that in first grade. I know because I have a first grader. That's algebra. She's doing algebra right now, right? That's what it is. When you think, what does it need to be to make 11? 2. All right? That's algebra. So that's the game here. Let's move over to B because I have more room. Let's find the x-intercept for B. You're trying to say, what makes 0? So for y to be 0, what has to be true? You could just solve for it, but I want you to think about it instead. So what needs to be in here to ultimately make this come out to be 0? What has to be in that box? A 0, right? Well, how are you going to make 1 minus x squared 0? What does x need to be? 1 is a possibility, because 1 minus 1 squared is, say 0. The students say 0. And another one is, what else squared? Negative 1, right? Because negative 1 squared is 1. And what's 1 minus 1? 0. Those are your two x-intercepts for that problem. We thought about it. Or you could solve for it. The question was, on a test, do you have to write both answers? Yes. They have to both be there. Because it says, find the x and y intercepts of the graph. And if you only find one, and there are two, you didn't find them all. Any other questions? Seeing none, we'll stop.